Hello everyone, my name is Charles Rotich from the Technical University of Kenya, pursuing Masters in Material Science. Okay, the title of my project is the band structure of 4D transitional max faces. So that's also my objective, whereby I determine the structure of the band structure of the max faces using AiiDA workflow. Here we are going to utilize Quantum Espresso code and AiiDA as a tool. Can define workflow as a series of activities that are necessary to complete a task. Each step in a workflow has a specific step before it and a specific step after it, with an exemption of the first and the last step. In my research, I had to create the band structure workflow, which will help me to do my research. My workflow had 4 steps. We can say a chain. Each step is like a chain. We call it a work chain, which the first work chain helped me to run a relaxed calculation. Then the output of the first work chain is the input of the second work chain, whereby we'll find the symmetry of the relaxed structure and find the standardized cell using SIGPath. The next step, the next work chain, was to run the SCF calculation, and the last step now was to run a band structure calculation, whereby now I'll obtain my energy and asymmetry points that will help me to plot a band structure. A workflow error handling. In workflow, errors can be handled automatically, or if it can be handled, you will receive an exit a code that with a message that will help you to know where the error is, if it's in the first work chain or the second work chain or the third work chain, depending on your workflow. So when you first launch the calculation, if it goes is it successful or not successful, you will receive the results. If it's not, it will try to handle the error. Then if it handle the error, it will launch again. If it will not handle the error, you will receive a code, for example 400, and that it gives you the message that inform you maybe you have to increase the band number of bands, for example, or it didn't find the pseudo potentials, an error, for example, like that. Okay, in AiiDA we have a provenance graph. Provenance graph helps to keeping track of data provenance, entails being able to recreate the whole history of any calculation or scientific finding, including all the steps leading up to it and all the parameters used in the intermediate computation. And here you'll see the yellow ones are the parameters, dictionary of the values, the source ICSD, the white ones contain your pseudo files, your UPF, and here you see your calculations, then your results. This is just an example, and everyone like results will have its node. For example 1020, if you want to see the results in this, you just use that node, whereby you will have to record it somewhere. Now these are my band structures. My calculation was successful. I obtained the results. These are my band structures for all the max faces. You can observe it clearly. Okay, let's see this one. We all plot an energy against the asymmetry points. These are against the asymmetry points. This is my Fermi energy, and you can see you don't have a band gap. Okay, from
The conclusion from my research is that the graph of the max faces band structure from the results show that it has no direct gap, and the band gap is 0.0 electrovolt, suggesting that it is all metallic. Thank you.